Welcome back to the Windows Partner Training Series. This is Module 10, Enterprise Mobility and Mobile Device Management. My name is Dave Field from Microsoft Partner Services. In this module, we're going to discuss an introduction to mobile device management in Windows 10 and how this works. We'll look at our mobile device management solutions, Microsoft Intune, as well as how we support third-party management platforms. And then we'll get into the management architecture for Windows 10 and how we support the open specifications or the open standards such as the Open Management Architecture Device Management Spec. We'll look at setting policy for Windows 10 mobile device management, and then we'll get into a lifecycle approach for managing mobile devices. So to start with, let's talk about how things have changed for Windows 8.1 to Windows 10 as we approach mobile devices. The story for the down-level systems was kind of spotty. We had better support on phone for Exchange Active Sync, device lock, and features such as that. Desktop didn't have a really good story for mobile device management. So we invested a lot of effort and time into bringing the standard for mobile device management in Windows up to a fully managed corporate device specification where the mobile device management stack can actually manage in a granular fashion almost to the point of the things we used to be able to cover with group policy and other management tools. So it's a very complete and thorough management stack that we have now. Some of the options when we talk about Microsoft Intune specifically for joining mobile device management with Windows 10. We have the capability in the OS to use the Connect to Work or School option in Windows settings to join mobile device management. We can also automate this as part of joining Azure Active Directory, and we'll talk about that in this module as well. We can do it as part of the out-of-box experience, and we can also do it by going to the Windows Store and downloading the company portal and signing up there. So there are a number of ways our users can join their devices to mobile device management and to basically give us the best experience possible for whatever our needs are for our organization. So let's take a look at a typical user experience with mobile device management. Our user here joins their system to Azure Active Directory, and in this case we would automate the mobile device management enrollment as part of this process. Some of the things they get with Azure Active Directory are the ability to log into their system using Azure AD credentials. We can set local administrators on the machine based on administrator accounts that we pull from the cloud. We can control who can and cannot log on to the device to add that extra measure of security. And we can enforce mobile device management enrollment as part of joining Azure AD. So the Intune enrollment itself brings a number of capabilities to us as well. Some of these are applying policy settings to the device. You can think of this as a corollary to group policy when you're on premises. We don't have a group policy in the cloud, so we use the Intune platform to manage many of the same settings. Store app deployment. We can deploy apps from the Business Store portal, or we can deploy apps from the Windows Store. We can also sideload or install MSI apps using the Intune platform. We can report on health against the device to compare that to compliance policies. This is part of the Windows Health attestation capabilities that come with Windows 10. And we can remotely wipe the device if it should be lost or misplaced. So once we've joined Azure AD and Intune Mobile Device Management, we've essentially tethered the device to the cloud. Through this interaction, the user can be in public locations, in office locations, working from home, and they get a consistent experience across all those locations. Through the facilities of Azure Single Sign-On, we can get access to Microsoft's first-party cloud services that are part of Azure. So also with our connection to the cloud, we have access to the Microsoft first-party cloud services as just as an extension of our identity platform into those services. We also have access to over 2,500 single sign-on applications that Microsoft has worked with to provide access in the application gallery to those vendors. So how do we make all this happen? In Azure Active Directory, we have a device registration capability. This is enabled by switching users may join devices to Azure, or users may Azure AD join devices to all. This process turns on the device registration service and allows Windows 10 systems to join Azure AD. You also can implement other controls at this stage. You can require multi-factor authentication to verify a user's identity before they can join a device. You can add additional administrators to Azure AD joined devices by selecting Azure user accounts at this stage. You can also control the number, the maximum number of AD joined devices that a user can join. To automate the mobile device management enrollment as part of this process, you would need to have Intune integrated as a Azure AD application gallery application. This screen shows the Microsoft Intune connection in the application gallery. If you look down the left of the display, you can also see Twitter, Salesforce, Workday, some of the other SSO applications that we've integrated in Azure. By choosing Intune and going through the configuration wizard, you enable the automated enrollment of devices with mobile device management. So let's take a look at what's happening when a system enrolls in Azure and mobile device management. In this example, we have a Windows 10 system that we will join to Azure Active Directory and Microsoft Intune. A user provides the username and password that is recognized by Azure for enrollment. Azure might challenge with a multi-factor authentication if that's been configured. After this challenge has been met, the Azure returns an Active Directory or an Azure Device Registration Service token to the device, and as well as local administrator accounts and mobile device management credentials and URLs. Windows 10 reaches out to the device registration service using the token that was provided. The device registration service writes a device object into Azure AD, and then returns a certificate to the client to allow the client to prove its identity to Azure in the future. In the next step, we start enrollment for mobile device management. So we connect to Azure for a single sign-on token that will give us access to mobile device management. After receiving the token, we reach out to the mobile device management agent and start the mobile device management enrollment process. In this case, Intune is the agent. Intune responds by enrolling the device and then starting to push policies to the Windows 10 device. These can be compliance policies as well as configuration policies that would be needed to configure the device to corporate standards. So let's take a look now at the language that we're using to enroll and manage mobile devices with Windows 10. The Windows 10 mobile management architecture is an extension of the new management architecture that we've created for Windows 10. At the base layer, we have the configuration service providers that control the configuration on the system. This could be registry settings, it could be files that are copied, it could be even taking inventory or collecting information from some of the system services. This layer reports to the Common Device Configurator, which is in essence a broker that allows multiple configuration platforms to speak to the configuration service provider layer. In this example, we're looking at the mobile device management client, which is a standards-based inbox agent for mobile device management. So let's take a little more detailed look at what happens as we look at this process. The configuration service providers read, set, modify, or delete configuration settings on the device, and they communicate with the management platform using the syncml language specification. The syncml messages are essentially XML-based messages that contain all the information we need to configure a configuration service provider on the system. So in this case with Microsoft Intune, we're receiving a syncml message from the Intune portal, which is received through the mobile device management client and fed into the Common Device Configurator. The Common Device Configurator in turn reaches out to a specific configuration service provider, in this case the Remote Find CSP, and queries it for some information. So looking at this from left to right, you can imagine that this syncml message was probably set to find the location of a device, getting the latitude, longitude, and maybe the age of the record that is stored in Intune or in the device to see when this device was last polled for this information. And what might be returned from this would be 20 minutes ago, this device was sitting in Central Park, New York City. So on the Intune side, a configuration policy might look something like this. It's basically a collection of settings that we use to configure and build the security policy. Some of the settings can be, as we see here, minimum password, age, allow simple passwords. These are just examples of what a mobile device security policy would look like. As we go through this process, we'll follow this specific policy into the syncml message and see what it looks like there. So in this case, minimum password length of 6. When we look at this in syncml, we're actually seeing that we have a number of items that we need to point out. The first is the device itself. What device are we speaking to? So this would be the actual device we're targeting with this policy. The next item is the Open Mobile Alliance Uniform Record Indicator, or OMA URI. This is the full path to the CSP on the system. These are standards-based. Vendor Microsoft is our address, if you will, and the rest of this is basically the internal address to the CSP. And then finally, if we look a little farther down, we see the value of 6, which is the value we're setting for minimum device password length. So now we'll take a look at policies and where we find these in the Intune portal. We'll do a quick demo later as well to show where the Windows 10 policies live, as well as how to customize some Windows 10 policy items. In this case, we're creating a OMA URI setting for a specific policy. This might be done when we don't have a policy template in place that configures the specific setting we're looking for. The custom URI settings for Windows 10 devices can be found in our custom URI setting reference on TechNet. This is kept up to date with what the current version of Windows 10 is providing. It also can be cross-referenced with the Configuration Service Provider reference, which is a complete list of the CSPs in Windows 10. And then finally, if a user is curious on their own system which CSPs are implemented, they can find the complete list in the registry. So we'll switch screens now and do a demo for mobile device management policies. So let's take a look at setting a configuration policy for Windows 10 using the Microsoft Intune portal. By going to the configuration policy settings, we can see some of the policies that have already been configured for our environment. When we click Add, we have the opportunity to view all the different types of policies that Intune can create. We'll focus on Windows 10 for this demonstration and just do a quick browse of the type of policies that we can create for a Windows device. As you can see, Microsoft Intune has some templates for Windows 10 management. We have the Enterprise Data Protection template, which controls the upcoming Enterprise Data Protection features for Windows 10. We have General Configuration, which manages the basic settings for Windows 10. And then we also have a configuration or a certificate profile setting that controls the management and distribution of certificates for Windows 10 devices. And finally, we have a custom configuration, which allows us to provide the raw OMA URI settings that might not exist in one of the policy templates. So let's take a look at a general configuration policy. We'll create this as a basic policy without recommended settings, just to show the complete template in its bare form. The first thing we would do when we log in to create this policy template would be to provide a name for the policy. As we scroll down the screen then, we can see some of the policies that we can configure. In the security section, we have a number of items around password controls. If you're curious about what any of these items do, you can hover over the tooltip and get a quick description of what the policy covers, as well as the recommended value. So you can browse those. To set a policy, you simply drag the slider or click to the right or left of the slider to pull it into the on or off position. In this case, require password to unlock devices. We'll leave this set to yes. And perhaps we'll set a minimum password length of 6. And this would allow us to set that 6-digit password that we saw in the earlier example. Clicking Save Policy then creates the syncml language packet for this policy and saves that in Intune. The next option is to deploy the policy. You can choose to not deploy the policy at this point and do some additional management before you deploy, or you can go ahead and say yes to deploy the policy now. You would choose the device group that the devices live in. In this case, we'll focus on all mobile devices. Click Add to create the advertisement for this, and then click OK to transmit. This policy is now being transmitted in real time to all devices in the mobile device management group and making the policy change that we just created. The other type of policy that we briefly mentioned is a custom policy. So let's take a look at this as well. In the custom policy section, when we create a policy, what we see is more of a bare bones experience for setting up a policy. So we'll call this Demo of Custom, and then we'll add a policy. So for this, we actually see the raw OMA URI setting. And it's quite likely when you get to this stage that you might not exactly know which setting you need to get. So where do we go for this? We have a link in the OMA URI settings section of the page that will take you to all of the OMA URI settings for Windows 10. And you can use this link to research the policies you would like to create. As we scroll down this page, we can see that there are quite a number of policies that we can configure, hundreds at the last count. And simply browse this list to get the policy that you'd like to set for Windows 10. For this demonstration, let's look at setting a policy. For device lock, allow idle return without password is a setting that controls the grace period during which a user can return to their session without logging in again. So the best approach here is to take the full URI path and copy this into the clipboard. Also make note at this time of the data type, the allowed values, and the default value for this policy. Default would be to allow the grace period. Putting a 0 here would block the grace period. So we go back into Intune, we add a policy, and let's just call this allow grace period. Data type was integer. OMA URI is what we copied into the clipboard, and then we'll set this value to 1. By setting this policy and saving it, we are now configuring this policy for Windows 10. We have the option to deploy the policy now. We select all mobile devices and say OK. And we've distributed this mobile device policy to our Windows 10 devices. So let's take a few minutes to look at mobile device management lifecycle. In the Microsoft mobile device management approach, we look at a device in basically a life cycle from enrollment to unenrollment. As we look at each of these phases, a number of things are happening as we go through this life cycle. In the enrollment phase, this could be the approach we use to enroll the device. One way could be using the Windows Image Configuration Designer to create a provisioning package to bulk enroll a number of devices. We could also enroll as a user-driven process by going to the Windows Store and installing the company portal, or we could use Azure Active Directory Join to push mobile device management enrollment as part of joining Azure Active Directory. Moving into the inventory phase, this is where we scan the device and compare its compliance to our compliance policies and make decisions regarding access to corporate assets based on these policies. Moving into the device configuration and security phase, this is where we could bring a device into compliance with corporate standards or deploy things for users like Wi-Fi profiles, virtual private networks, email, and so forth. Moving into the application management phase, this is where we would deploy applications perhaps from the business store portal, sideload applications, push MSI applications onto the device using the mobile device platform. Moving into the life cycle of the device, a typical thing that might happen there would be the device gets misplaced or stolen. We have the ability to ring, reset, find, or wipe the device during this phase. And then finally, at the end of a device's life cycle for the organization, we can unroll the device, remove corporate applications and data from the device, and return it either to a factory condition or to the condition the user had when they joined the device to our systems. Going into a little bit more detail on a few of these sections. During the inventory phase, this is just a subset of some of the information that we can retrieve from a device. Battery level and battery health, secure boot status, device screen resolution, details around OEM, model number, device type. This is just the beginning of some of the things we can receive from an inventory configuration service provider. In the device configuration security phase, some of the things we can look at might be configuring the passport and hello capabilities of the device. Doing some update management, getting the device up to standards for patches, for instance, controlling enterprise data protection features, even configuring the health attestation capabilities for the device. Going into device configuration, security policies, virtual private networks, even turning on kiosk mode to lock an application as the default user experience for a device. A very helpful feature for customers that might want to have a single-purpose device around point of sale or inventory or something like that. A little bit more about the health attestation service. In the past, if we needed access to documents or email, the typical approach was we requested access, and if our username and password checked out, we were in. This did not, however, keep us from infecting assets within those services. So a system with malware could easily have spread that through these capabilities or through these platforms. With health attestation, we can take an extra step to ensure that we have health on the device before we allow access. So in this scenario, the device or the user on the device requests access, and instead of just granting access, the service asks for a health certificate. The device then reaches out to the mobile device management service and does a check with the health attestation configuration service provider, during which a number of compliance rules can be checked. Is the device up to date with patches? Has the firewall been enabled? Is antivirus enabled, and is the system rated clean by antivirus? If all this checks out, then the device receives the health attestation and can prove to the resource that it's trying to connect to that it has the required health to meet that resource's requirements. All right, so let's take a look at what EDP looks like, or Enterprise Data Protection looks like, when we're looking at a device platform and how we're managing this segmentation between enterprise or organizational data and that data which is considered private. As we look at enterprise data protection, we have this concept of a separation between work and personal applications. This is done through management policy, and the applications themselves can be enlightened to understand how to manage data appropriately based on this policy. So we have a kind of a concept of a managed application, which we control through this policy, which understands its role with corporate data. Data would be flagged as corporate or personal. Data coming onto the device would be stored as corporate data with corporate encryption keys placed on it, and personal data would be stored in normal format. Going forward, if data was to be transitioned from the protected policy to an unprotected status, it could be blocked completely or it could be audited. So as these policies are configured, you would determine what happens to these capabilities. If data is audited, the user would be alerted to the fact that it's an audit policy, that their transmission of data from a corporate storage to a personal OneDrive or maybe over personal email would be an audited action, and then they could choose whether they wanted to still do that. And with integration with Azure Rights Management Services, you have the capability of transmitting this data in a business-to-business scenario or even to unprotected storage, as long as that Azure RMS or Rights Management Services capability is involved, because that maintains the encryption into that channel. And finally, you can have network policies to require that data might be transmitted only over a VPN connection, for instance, so that it would never be over a public unencrypted internet feed, as an example. So in the unenrollment phase, we have a few choices. We can block unenrollment of devices to keep a device compliant with corporate security policies, in which case only an administrator would be able to unenroll. Or we could allow an enrollment, either from within the device by deleting the workplace account, or from the company portal, where the user would log into Intune, find their device, and remove it from there. During removing a device, we have two choices. One would be to completely wipe the device and return it to factory settings. The other would be to selectively remove only the workplace data, applications, and configurations from the device and return it to the user in a consumer state. So along with this process, we've enabled smarter asset removal. We recognize the settings and configurations that we've pushed to the device and are able to extract those individually and remove those without affecting user data. This can include certificates, VPN, Wi-Fi profile, even enterprise data protection, partitions, and configuration settings. Administrators can do an unenrollment from Intune itself, or users can unenroll from the company portal or from the device. And the experience is consistent between Windows Mobile, Windows desktops, and even out to third-party devices, iOS and Android. They all take the same approach when they're working with Microsoft Intune. As an additional option, we can also trigger an unenroll when a user removes their system from Azure AD Join. So by deleting their Azure AD affiliation, they would move on into unenrolling the device from mobile device management and stripping away all of the corporate apps, data, and configuration settings. This completes our pass through Windows 10 mobile device management with Microsoft Intune. As we've seen in this session, we went through how to enroll a device, what happens to the device with policy after it's been enrolled, and finally unenrollment and deprovisioning of the device. We looked at open management with the mobile device management capabilities of Windows 10, and we looked into how to configure policies in Microsoft Intune. Thank you for joining us for this module.